Hi, and welcome to section 5.4. We're talking about dividing polynomials. So we're going to get into it. Let's just start right away. So first thing we're going to talk about is dividing monomials or single terms. And the best way to do that is basically to write them as a fraction or a ratio or a rational expression, however you want to say it. So see here, 54a squared b cubed is divided by 6ab to the fifth power so 54 divided by 6 is negative 9. And then you have a squared over a, so 2 minus 1, so that's just a. And then b cubed over 5, that's 5 minus 3 is 2, but since it's in the denominator, because the larger number is in the denominator. So that's it. Let's do this one here, 14 and 21. The common denominator is 7, so divide by 7, top and bottom, you get 2 over 3. X to the 7 over x to the 11th. 11 minus 7 is 4, so that'll be in the denominator because 11 is in the denominator. And then you have y's. 12 minus 6 is y to the power 6. Okay. What if you have a polynomial divided by a monomial? So what you would do is basically, if you have 18x cubed y minus 36xy squared, and that's divided by some monomial, it's the same thing. You can split both of the terms and divide both of those terms by that monomial. So then that's minus, and then you have 36xy squared divided by negative 3xy. Okay, so that's the case. Then you have here, negative 3 divided by 18 divided by negative 3 is negative 6. X cubed over x, that's 3 minus 1, it's x squared. And then the y's just cancel out. This negative and a negative become positive. 36 divided by 3 is 12. The x's cancel out. And then y squared divided by y, that's just y. Okay? So next we're going to introduce dividing polynomials using long division. And I know everybody's excited because everybody loves long division. So let's first go over the steps of dividing by long division. Okay, so remember, let's say here we have 875 divided by 25, okay? So if we have that, how do we do this? So remember, this is the dividend, 875 divided by the divisor, and then quotient is the answer, right? So we went into pieces. So 25 goes into 87 3 times. 3 times 25 is 75. Subtract, bring down the difference. 25 goes into 125 5 times exactly, and then your remainder is 0. So it's this pattern, right? So let's go ahead and do one. So we're dividing, this is our dividend and this is our divisor. So basically, we're dividing x squared plus 9x plus 20 by x plus 5. So the first thing you do is figure out, look at the first term, the first two terms, and say, you think what number times x gives me x squared? We want it to be the same thing because we're going to subtract it out, okay? So you can do that. You can put in the dividend divided by the first term and then say, oh, okay, this is the number I need or the letter that I need. So what I'm going to do is I'm going to place an x in the x column, and then I'm going to multiply that x by this entire x plus 5. Okay, so then that's going to give me x times x plus 5 is x squared. Don't forget to distribute, plus 5x. Now, what do we do here? We subtracted, so we're subtracting it. When we subtract, it changes the signs. So then that will cancel out here. 9x minus 5x is 4x. I'm sorry, 4x. And then we bring down the 20, so plus 20. So then we do the same thing all over again. Okay, so how many times does x divide into 4x? Okay, 4. And some people say, well, why don't you count the 5? Well, that's because I'm trying to eliminate the first term, okay? And so that's why I look at the first term only. So plus 4. So then I multiply 4 times x plus 5. That gives me 4x plus 20. So subtracting, changes signs. My remainder is 0. So the quotient is x plus 4. Okay. Let's do another one. So here we have x squared plus, x squared, x to the power 4 minus, well, there's no x cubed, so I'm just going to put a 0x cubed. This is important because the exponents needs to go from 4, 3, 2, 1, 0. And that's because when you're dividing, you need that. So x plus 2. So again, what times x gives me x to the power 4? So see, it's x cubed. So I needed this 0 placeholder, okay? Okay, so x cubed times x plus 2. That's going to give me x to the power 4 plus 2x cubed. Oh, I don't know what just happened. What just happened? Okay, there it is. And then we subtract. So subtracting changes the signs. Come on. And then these cancel. 0 minus 0. X cubed minus 2x cubed just gives me negative 2x cubed. So let's bring down minus x squared. And we can bring down the rest if we want, but for now, we're just going to do two terms. So what number times x gives me a negative 2x cubed? So basically, I'm asking negative 2x cubed over x is equal to what? So it's the same thing, just less one, exponent, so minus 1. So this is negative 2x squared. So I'm going to multiply this negative 2x squared by x plus 2. So then that's going to give me negative 2x cubed minus 4x squared. So then change the signs because I'm subtracting. That changes these signs to positives, canceling the first term, which is what we wanted. So that brings me to 3x squared here. And then I'm going to bring down the rest, plus 5x minus 6, even though I'm probably not going to use a 6 right away. So then what times x, we go through the whole process again, gives me 3x squared. So if I multiply x, if I multiply this x by 3x, then that'll give me the 3x squared that I want. 6x. Okay, so this is what I'm doing. Again, remember, I'm multiplying this 3x times the quantity x plus 2, and I'm writing it here. Then I change the signs because I'm subtracting it. So that cancels out. 5x minus 6x is just negative x minus 6. Bring down that. So then in order to get negative x, I need to multiply the outside x plus 2 by negative 1. So that gives me negative x minus 2. Change the signs, because when you subtract a negative, it becomes a plus. These cancel, and you get negative 4 as your remainder. Final answer is x cubed minus 2x squared plus 3x minus 1. And then the remainder is minus 4 over x plus 2. So that's the remainder part. In the last problem, we didn't have a remainder, so that's why we didn't really use it, okay? So all of that. So now that we've seen long division, I'm going to introduce synthetic division, which is going to make it a lot easier, okay? So synthetic division is similar. We keep the coefficients of the original, and then, so let's say here on the left-hand side, you have a long division problem, right? Synthetic division means divide by, if you have a linear term, the opposite, so that's negative 5. And then you write down the coefficients of the dividend, and then bring down multiply, add. So I'll show you what I mean. I'll do an example. So if I divide by x minus 2, synthetic division means I have to divide by negative 2 because the form is negative x minus a. So in this case, a would be negative 2. And the coefficients are, so you have 2, 3, 1, and then 8. Okay, and then notice the exponents go 3, 2, 1, 0. So that's fine. So you would write your exponents here, your coefficients here. Okay, and you draw a line. So then the first value always comes straight down. So that's a 2. And then to get to the inside, you would multiply. So 2 times negative 2 gives me negative 4. And then I combine. So then 3 minus 4 is negative 1. Then negative 1 times negative 2 is positive 2. So I'm taking this number, negative 1, and I'm multiplying it by this, and that gives me this answer here. So 1 plus 2 is 3. 3 times negative 2 is negative 6, and then your remainder will be 2. Okay, so final answer. So this was a cube to begin with, so your answer is going to start with a squared because you divided by a linear term. So your answer will be 2x squared minus x plus 3. And then this is the remainder. So that would be plus 2 over, and then whatever we divided by, in this case, x plus 2. Okay. All right, let's do another one. Actually, that was supposed to be a long division, so we'll do this one here. Use synthetic division to, did we just do that? I think we just did this one. Yep, 2, 3, 1, 8. Okay, sorry. So then finally, well, the book might have some more examples here. Let's talk about division of polynomial functions using the function notation. So just how before we did multiplication, here it looks like this, f over g of x. That means f of x over g of x. So let's say we have f of x and g of x is x plus 2. So f over g of x is going to basically be x squared minus 5x minus 14 all over x plus 2. So one way we could also solve this is we could factor the top. If I factor the top, I get x minus 7 x plus 2 all over x plus 2, and then these cancel out. So my final answer, so f over g of x is equal to x minus 7. Okay, so that's A. And then B, f over g of negative 4. That just means I use A and plug in negative 4. So then that's negative 11. Okay. All right. Remainder and factor theorem. So notice the following. If I divide x to the 4th minus x squared plus 5x minus 6 by x plus 2, my remainder is negative 4. If I plug in negative 2, my solution is negative 4. So, okay, so look at the next one here. If I divide 3x cubed minus 2x squared minus 10x plus 8, if I divide that by x minus 2, my remainder will be 4. But if I take that same thing and I plug in 2, then I also get 4. So again, I divide by x plus 4, I put in negative 4, and I get the same value. So basically, the remainder theorem is that the remainder matches, it's the same exactly, the remainder of dividing synthetically or using long division, when you find the remainder, it's the same value that you would get as if you inputted a value, the x minus a value. So let's say what I'm trying to say here. So use the remainder theorem to find the remainder when f of x is divided by x plus 2. So the remainder theorem states this, okay? So if I divide this by x plus 2, let's show that using synthetic division first. Okay, since we wanted to do another synthetic division. Anyway, so notice there's no x squared term, so I put a 0 there, that's why. Okay, so bring down the 1. The first one always comes down. 1 times negative 2. Bring that down because it's 0. Negative 2 times negative 2 is positive 4. 3 plus 4 is 7. 7 times negative 2 is negative 14. And then the remainder is 5. So that's, that's the remainder. But then according to the theorem, if I plug in negative 2 into f, I should also get 5. So negative 2 cubed plus 3 times negative 2 plus 19. So then that's going to be negative 8 minus 6 plus 19. That's going to be negative 14 plus 19. So that's 5. So see, they match. All right. This is supposed to be a check mark. Okay, there. Also, a special case of the remainder theorem is the factor theorem. So basically, if you have a term that evenly divides into a polynomial, then it's considered a factor. And not only that, the function evaluated at this point is equal to 0, which makes sense because if it's a factor, that means that f of x is equal to, x minus c times some other function. We don't know, whatever the dividend is, or, the quotient is, I'm sorry. So then if you plug in C, then you'll get 0 times something, so you'll still get 0. Okay, so it works both ways. So if I plug in a value and it equals 0 into F, that means that X minus that value is a factor. So there's two ways. I can divide directly, or I can just plug it in. So since I have this, I want to know if X minus 4 is a factor. If X minus 4 is a factor, then by the theorem, F of 4 should equal 0. And if it does, then we know that it's a factor. So this is 64 minus 64, which is 0. So yes, X minus 4 is a factor. Okay. All right, and that's it for this section here. Here's your super fun homework. Good luck, happy studying, and I will see you on the next video.